Yellowstone is not a mountain waiting to explode. It is much stranger than that. Every year, millions of people walk over one of the most restless places in North America. They take photos of geysers, stand beside rainbow-colored hot springs, drive past forests and bison, and sleep in hotels built above an underground system powered by ancient volcanic heat. And somewhere online, someone is always saying the same thing. Yellowstone is overdue. Yellowstone is about to blow. Yellowstone could end the world. It sounds terrifying because the word people use for it sounds terrifying. Supervolcano. It feels like the final boss of geology, a volcano so large that normal volcanoes seem polite by comparison. But the real Yellowstone is not a ticking bomb. It is a living system of hot rock, water, gas, earthquakes, geysers, pressure, and time. And if Yellowstone erupted, the first weird truth is this: it probably would not look like the disaster movie in your head. To understand what would really happen, we have to separate three very different dangers that people often mix together. Hot water explosions, lava flows, and the famous giant supereruption. They all belong to Yellowstone's story, but they are not the same event. The smallest version is not even a true volcanic eruption. It is called a hydrothermal explosion. That word sounds complicated, but the idea is simple. Under Yellowstone, water sinks into the ground, gets heated by volcanic rock, and becomes trapped under pressure. If that pressure is suddenly released, the water can flash into steam almost instantly. When water turns into steam, it expands violently. Rocks, mud, boiling water, and steam can blast out of the ground without warning. No lava has to reach the surface. No giant ash cloud has to rise into the sky. It can happen because Yellowstone is full of superheated water looking for a way out. That is why the park has boardwalks. They are not just there to protect the pretty pools from tourists. They are there because the ground can be thin, unstable, and dangerously hot. A calm-looking patch of crust can hide boiling water beneath it. In June 2026, a small hydrothermal explosion happened in Biscuit Basin. It threw rocks into the air and sent sediment-rich hot water into the Firehole River. That sounds dramatic because it was dramatic, but it was not magma rising to destroy civilization. It was Yellowstone's underground plumbing system doing something violent and local. This is one of the strange things about Yellowstone. The realistic danger today is not usually the giant eruption people imagine. It is the hot, unpredictable ground beneath your feet. Now, what about a real volcanic eruption? If magma did reach the surface at Yellowstone, scientists say the most likely version would be a lava flow. Not a planet-ending blast, not instant darkness over the world. A thick, slow-moving flow of lava, probably inside or near the park. That would still be serious. Roads could close, forests could burn, gases could become hazardous. Entire areas of the park could be evacuated and changed for generations. A lava flow could bury trails, reshape valleys, and turn familiar places into a black, steaming landscape. But lava is not a tidal wave. It usually moves slowly enough that people can get away. The disaster would be real, but it would mostly be regional. It would be a major emergency for Yellowstone, nearby communities, scientists, park staff, and emergency services. It would not be the end of the United States. And this kind of smaller eruption fits Yellowstone's more recent volcanic history. Since the last giant eruption about 640,000 years ago, Yellowstone has produced many smaller eruptions, mostly lava flows. The most recent volcanic eruption there was around 70,000 years ago on the Pitchstone Plateau. That is still ancient to us, but in geology, 70,000 years is not the same as never. Then there is the famous nightmare, the giant caldera-forming eruption. This is the version people mean when they say Yellowstone supervolcano. It would happen if a huge amount of magma erupted so quickly that the ground above the magma reservoir collapsed downward, forming a vast volcanic depression called a caldera. Yellowstone has done this before, not once but multiple times in its deep past. That is why the place has such a massive volcanic reputation. If an eruption like that happened today, the first hours would be almost impossible to imagine. Near the eruption zone, explosions would blast ash, pumice, and volcanic gases into the atmosphere. Pyroclastic flows, which are fast-moving currents of hot gas and volcanic debris, could devastate areas close to the eruption. The landscape inside and near the caldera would be transformed. Nearby states like Wyoming, Montana, and Idaho would be hit hardest. Heavy ash could bury roads, collapse weak roofs, contaminate water supplies, damage engines, and make breathing dangerous without protection. And volcanic ash is not soft, fluffy campfire dust. It is tiny broken rock and glass. It can scratch metal, choke machinery, short out electrical systems, irritate lungs, and turn wet roads into a heavy gray paste. Even a few inches of wet ash can become heavy enough to strain buildings. Farms far from the park could be affected because ash can cover crops, pollute water, and harm livestock. Air travel would become chaotic. Jet engines do not like volcanic ash. Flights across large areas could be grounded. Supply chains could be disrupted. Power systems and communication infrastructure could face stress. Clean water, masks, shelter, and food distribution would become urgent problems in affected regions. The effects would not stop at the park boundary. A huge Yellowstone eruption could send fine ash across parts of North America. Depending on wind patterns, some places would get heavy ash, some would get a thin coating, and others might get almost none. The map would not look like a perfect circle spreading from Yellowstone. The atmosphere is messy, and the wind decides where the ash goes. Then there is climate. A giant eruption could inject sulfur gases and fine particles high into the atmosphere. Those particles can reflect sunlight and cool the planet for a while. USGS says a giant Yellowstone eruption could cause short-term global climate effects lasting years to decades. That sounds like science fiction, but volcanoes have changed climate before. The difference is that Yellowstone's giant eruptions belong to deep geologic time, not human news cycles. And this is where the internet usually makes its biggest mistake. It treats Yellowstone like a clock. It says the volcano erupts every certain number of years, then points at the calendar and announces that we are overdue. But volcanoes do not follow calendars. They are not trains. They are not oven timers. The giant eruptions at Yellowstone were separated by huge, uneven gaps of time. With only a few giant events in the record, you cannot build a reliable schedule and call it destiny. USGS estimates the annual probability of another giant caldera-forming eruption at about 1 in 730,000, or around 0.00014%. And even that number is a rough estimate, not a prophecy. There is no evidence that a catastrophic Yellowstone eruption is imminent. As of the July 2026 Yellowstone Volcano Observatory update, Yellowstone's official volcano alert level was normal, with an aviation color code of green. Scientists reported background levels of seismicity and no significant uplift or subsidence of the caldera or North Caldera rim since January 2026. That does not mean Yellowstone is dead. It means Yellowstone is behaving like Yellowstone. The park has earthquakes, the ground rises and falls, geysers change, hot springs shift, steam vents open. Thermal areas can surprise people, a place can be active without being on the edge of apocalypse. This is why monitoring matters. Scientists watch Yellowstone with seismometers, GPS stations, gas measurements, satellite observations, stream sensors, and field surveys. They are looking for patterns that would be much bigger than normal background behavior. Before a major eruption, scientists would expect warning signs. Not just one weird geyser, not just a small earthquake. They would look for intense earthquake swarms, rapid ground deformation, unusual gas changes, and other signals that magma is moving in a serious way. A giant eruption would probably not arrive like a jump scare. The Earth usually leaves clues. But clues are not the same as certainty. Volcanoes are complex. Scientists can monitor risk, detect changes, and issue warnings, but no one can predict every detail perfectly. That is what makes Yellowstone so fascinating. It is not fake danger. It is real danger wrapped in very long timescales. So what would really happen if Yellowstone erupted? The answer depends on which Yellowstone you mean. If it is a hydrothermal explosion, the danger could be sudden, local, and deadly to anyone nearby. It might blast rock and boiling water across a thermal area, damage boardwalks, and change a hot spring or geyser basin. If it is a lava flow, the park could face a major eruption crisis. Areas would close, people would evacuate. Landscapes could burn, crack, and be buried under new volcanic rock. It would be historic, dangerous, and deeply disruptive, but probably survivable with monitoring and distance. If it is the giant supereruption, the consequences would be enormous. Heavy ash near Yellowstone, major disruption across parts of North America, possible global climate effects, and years of recovery. It would be one of the most serious natural disasters humans have ever faced. But it is also the least likely version. That is the strange balance of Yellowstone. The biggest story is not the most likely story. The real danger is not always the one with the biggest thumbnail. Yellowstone is powerful enough to inspire nightmares, but precise enough to punish lazy explanations. It is not a bomb under America. It is not overdue in the way people say online, and it is not harmless just because the supereruption is unlikely. It is a restless underground world, where water can explode, rock can melt, the ground can breathe, and the planet quietly reminds us that it is not finished changing. The scary part is not that Yellowstone will erupt tomorrow. The scary part is that Earth has been building places like Yellowstone for millions of years, with or without us watching.